calculator company determined that the demand function D for selling calculators at a price P is given by this equation D evaluated at P is equal to negative 8P squared plus 250P. We are going to be using this average rate of change formula in this example, but the first thing that we're asked to do is to graph the function using this window setting. So on our calculator, we're going to come over to the y equals and input our demand function. So this will be y is equal to, we have to say negative 8x, the independent variable on our calculator is x, squared plus 250p, which is going to be 250x. And then we want to use the designated window setting. So let's come over here to window. And the first group of numbers represents the x minimum, the x maximum, and the x scale. The second group of numbers represents the y minimum, the y maximum, and the y scale. And so once we've entered in all of those values, then we'll go back over to the graph in order to see our demand function. In part A, we're asked to find the value of P that maximizes the demand. Well, the P value is this independent variable axis, right? This is going to be the price axis, and we're looking for the price that causes the demand output to be at its highest point. On the calculator, the way that we do that is to use the calculate function, which is in blue up here above trace. In order to access that feature, we need to hit the second button and then hit trace, which accesses the calculate function. Now we're looking for the value of the maximum. So we're going to come down here to the fourth item on the list and then hit enter. We could also just have hit the number 4. Now we're being asked to answer some questions. The calculator wants to know what is a value that's to the left of the maximum that we're looking for, and anything to the left will do. This one is fine, so I'm just going to hit enter. Now it's asking for a value that's to the right of the maximum that we're looking for, so I'm going to come over here to the right and hit enter. And then it's asking me to take a guess at what we think that maximum value is. So we'll put our cursor pretty close to where that maximum is located and hit enter again. Now the calculator pops out the maximum ordered pair, which has an x value, but that x value is the value of our independent variable, which in our case is the P price. So the price that maximizes the demand is going to be 15.62 or $15.62. The y value that we get out would actually be what that demand is. And if that demand represents the number of people who want to buy a calculator, then we would say there are 1,953 people lined up to buy calculators at this price. In part B, we're asked to find the average rate of change from P is equal to 12 to P is equal to 18, and also explain its meaning. Let's recall our demand function was negative 8P squared plus 250P, and so if we're looking for the average rate of change between these two P values, what we're actually going to need to find is two ordered pairs where one of the ordered pairs has a p-value of 12 and the other ordered pair has a p-value of 18. Notice that ordered pairs with this demand function are going to be of the form where the independent variable is p and the dependent variable is the corresponding demand associated with that price. So to get our ordered pairs, what we're going to need to do is to plug 12 into the demand function to get the corresponding output. We'll also need to plug 18 into the demand function to get the output there as well. We can do this by hand, but since we have our calculator right here, let's demonstrate how we could come up with these values using the calculator. Again, we can use the second calculate function, and instead of the maximum this time, here we want to calculate particular values. So we'll select number 1 on this list. Now this brings us back to our graph, and we're able to plug in numbers for our independent variable. It says x, but we of course understand that to be p, the price. Hitting enter here, I get the corresponding output when x is equal to, or when p is equal to 12. So the demand function evaluated at 12 turns out to be 1848. We can do this again for 18. We can just plug 18 in and it's going to cycle us back through that same second calculate value feature. And now we have 1908 as the output, the corresponding demand when the price is 18. Now since both of these points were pretty high on my graph, I'm actually going to go to the window and change my y maximum to be a little bit higher so that we can see those top values. To find the average rate of change between these two price values, we'll use our average rate of change formula, which would be the demand at the second price minus the demand at the first price, divided by P2 minus P1. Remember, this average rate of change is essentially the same as our slope formula. And to think about it as the slope between 2 points, we could use 1848 in here and 1908 in here in order to complete these two ordered pairs and find the slope between them. So now we're looking at the demand at the second price, which is 1908, minus the demand at the first price, which was 1848, divided by the second price, which was 18, minus the first price, which was 12. Subtracting the values in the numerator, we get 60, and in the denominator, 18 minus 12 is just 6, so our average rate of change is 10. In order to explain its meaning, it benefits us to think about the units that were associated with these two variables. When calculating the average rate of change, we considered the change in the demand in ratio with the change in price. How is the demand measured? Well, the demand is measured in the number of calculators that are sold, and the price is being measured in dollars. So when we come back up here to the average rate of change, we can turn this into a fraction and essentially copy-paste the units for how the demand is measured, which is calculators, and how the price is measured, which is dollars. So what this means is that the demand increases by 10 calculators, since this 10 is a positive number, for each $1 increase in the price. Again, since this is positive, we're seeing an increase in the demand as the price increases. And this is how we would explain the meaning of that average rate of change. And back over here on our calculator, let's remember that when x was equal to 12, we had a point in this region, and then when x was equal to 18, it gave us a point over here, and we saw that the slope that connects those 2 points was a positive slope indicating an increase in the demand. In Part C, we're being asked to find the average rate of change again, but this time we're asked to find it from P is equal to 12, which we've already determined that that ordered pair was 12 and 1848. But the second ordered pair would be when the price is 25. So now we need to determine the demand when the price is 25 to complete the second ordered pair. So we come back over to our graph and we just put 25 in here to determine the corresponding y value. Again, that was using the second calculate value feature, and the corresponding demand is now 1,250. Again, we calculate the average rate of change in the same way that we would calculate the slope between 2 points. So we'll say 1250 minus 1848 over 25 minus 12. This time the numerator is negative 598 and the denominator is 13 positive. When we divide these two quantities, we see the average rate of change this time is negative 46. And again, we're going to use the fact that the average rate of change was calculated by looking at the change in demand in ratio to the change in price, and then copy-paste the units for measuring demand, which is by calculator, and the units for measuring the price, which is dollars. So now we can turn this average rate of change into a fraction, negative 46 over 1, where the numerator is measured in calculators, because that represents the change in demand, and the denominator is measured in dollars because that represents the change in price. This helps us to interpret our average rate of change to mean that the demand this time is decreasing because the average rate of change is negative by 46 calculators for each $1 increase in the price. And that's because in order to get a negative average rate of change, and we've already declared that the demand is the negative quantity, then the denominator has to be positive so that the overall ratio is a negative quantity. Now let's come back over here to our graph. Remember, one of the points was 12 and 1848, and when we evaluate the demand at 25 as the price, we see that the other ordered pair is down here, and this time the slope between those 2 points would be negative.